Good morning, students. Today lesson Unit 10. Today lesson Unit 10 Types of Chemical Reactions. Unit 10 Types of Chemical Reactions. The learning objectives: classification of chemical reactions. Classification of chemical reactions, physical change, chemical change, difference between physical and chemical change, a reversible reaction, irreversible reaction, action of hydrogen peroxide, a difference between a reversible and irreversible reaction. And liquid water freezes into ice. Water freezes into ice. Then ice melts into liquid water. One form is changed into another form. A liquid water freezes into ice, that is in the solid form. Then the solid form of ice melts into a liquid water. In other words, freezing is reversed. Freezing is reversed. So it is not a permanent change. It is a physical change. Physical changes can be reversed easily. Freezing is reversed. It is not a permanent change. It is a physical change. The physical changes can be reversed easily. The chemical changes can be reversed. Can chemical change be reversed? See the reaction. This is the chemical reactions. Chemical change. Now burning of wood. Consider the burning of a wood. The carbon compounds present in the wood are burnt into carbon dioxide gas and water. The carbon compounds present in the wood are burnt into carbon dioxide gas and water. Can we get back the wood immediately from carbon dioxide and water? It's not possible. We cannot. So, it is a permanent change. The carbon compounds present in the wood are burnt into carbon dioxide gas and water. Then, can we get back the wood immediately from carbon dioxide and water? We cannot. So, it is a permanent change. The chemical change is a permanent one. In most of the cases, we cannot. What are the difference between physical and chemical change? In a physical change, the molecules are rearranged while their actual composition remains same. In a chemical change, the molecular composition of a substance completely changes and a new substance is formed. In the physical change, some example of physical changes are freezing of water, melting of wax, boiling of water. A few examples of chemical change are digestion of food, burning of coal, rusting. In the physical change is easily reversible. That is, original substance can be recovered. Chemical change is irreversible. That is, the original substance cannot be recovered. In physical change, no new substance is formed. A chemical change is always accompanied by one or more new substances. In a physical change, no new substance is formed. A chemical change is always accompanied by one or more new substances. Physical change is a temporary change. Chemical change is a permanent change. Physical changes are temporary. Chemical changes are permanent. In a physical change, no energy is produced. In a chemical change, energy is produced in the form of heat, light, sound, etc. Physical change involves very little to no absorption of energy. During the chemical reactions, absorption and evaluation of energy takes place. Physical change affects only physical properties, that is, shape, size, etc. The chemical change, both physical and chemical properties of the substance, including its composition. So, important points: physical changes is easily reversible, chemical changes is irreversible. Example of physical change: freezing of water, melting of wax, boiling of water. For the chemical change, example digestion of food, burning of coal, rusting, etc. In physical change, no new substance is formed. A chemical change is always accompanied by one or more new substances. Physical change is a temporary one, chemical change is the permanent. In a physical change, no energy is produced. In a chemical change, energy is produced in the form of heat, light, sound, etc. Physical change, example, this is a chemical change. The physical change, water freezes and converted into ice, that is in the solid form. Then the solid form of ice melts into liquid form of water. One stage is converted into another stage, then it is written back into the old stage. So in the chemical change, burning of wood, if once burn the wood, it is never converted into the old stage of wood. So this is a major difference of physical and chemical change. Some chemical reactions can be reversed. Our mobile phone gets energy from its lithium ion battery by chemical reactions. Our mobile phone gets energy from its lithium ion battery. And the cell phone is also made up of lithium ion battery. It is called discharging. On recharging the mobile, these chemical reactions are reversed. Thus, chemical reactions may be reversed under suitable conditions. Some chemical reactions can be reversed. Our mobile phone gets energy from its lithium ion battery by chemical reactions. And this is the example for the chemical reactions. Sometimes it is reversed. Reversible reactions. A reversible reaction is a reaction that can be reversed. That is, the products can be converted back to the reactants. A reversible reaction is a reaction that can be reversed. The products can be converted back to the reactants. This is the example. A reversible reaction is represented by a double arrow with their heads in the direction opposite to each other. This is a reversible reaction represented by double arrow. This is double arrow, forward reaction, backward reaction. One is forward, another one is backward. With their heads in the direction opposite. The head of the first reaction is in the forward. The head of the second is indicate backward reaction. Totally, this reaction is called reversible. Forward reaction and backward reactions both also occur. So this is a reversible reaction. In this reaction, AB, this is the reactant. This is converted into A and B. In the reversible reaction, A and B reacted together to form AB. Examples of reversible reactions. 2H2 plus O2 give 2H2O. Hydrogen plus oxygen to form water. 2H2 plus O2 give 2H2O. The formation of 2H2O is forward reaction. Then the 2H2O then converted into 2H2 and O2. This is the backward reaction. N2 plus O2 gives 2NO. This is forward reaction. This is backward reaction. 2NO is converted back into N2 and O2. CaCO3. It is split out into in the forward reaction to form calcium oxide CaO and carbon dioxide. Then calcium oxide and carbon dioxide reacted together to form calcium carbonate CaCO3. Then N2 plus 3H2 to form 2NH3. This is forward reaction. 2NH3 is changed into N2 plus 3H2. This is reversible reaction. So two reactant react together to form a single compound. This is combination reaction. Two reactant to form a single compound. Single compound is formed. Here two reactant to form a single compound. Two reactant to form a single compound. These are also the example of the combination reaction. In the reversible reaction, in the first and the second, the single reactant involved to form more than one product. This is decomposition reaction in the reversible reaction. The third one, the first one is decomposition reaction. The reversible reaction is combination reaction. The formation of NH3. Two reactants are involved to form a single compound. This is combination. The reversible reaction, one reactant only involved to form two products. This is decomposition reaction. So forward and backward reactions both also occur in this reaction. So this is a reversible reaction. In this example, the compound AB undergoes decomposition reaction to form the product A and B. AB undergoes decomposition reaction to form A and B. It is a forward reaction. This is a forward reaction. As soon as the products are formed, they combine together to form AB. A and B combine together to form AB. It is a backward reaction. So the reaction takes place in both the directions. A and B, that is AB, is a reactant to form the product of A and B. Then in the reversible reaction, A and B are involved. This is the product. A and B are the product reactants to form a product AB. One is forward reaction, another one is backward reactions. The following decomposition reaction of phosphorus pentachloride PCl5 phosphorus pentachloride to form in the forward reaction to form PCl3 and Cl2. PCl3 and Cl2. The following decomposition reaction of phosphorus pentachloride PCl5 phosphorus pentachloride into phosphorus trichloride PCl3, phosphorus trichloride and chlorine. The forward reaction is the decomposition of PCl5. The forward reaction is a decomposition of PCl5. So PCl5 only one reactant involved to form more than one product, PCl3 and Cl2. So this is the decomposition reaction. And the backward reaction is the combination of PCl3 and Cl2. In the backward reaction, PCl3 and Cl2 combine together to form PCl5. So forward reaction and backward reaction both also occur in the same reaction. So this is a reversible reaction. The speed of both the reactions become equal. So PCl5 cannot be completely converted into the products as the reaction is reversed. It is a reversible reaction. It is a reversible reaction. The speed of both the reactions become equal. So PCl5 cannot be completely converted into the products as the reaction is reversed. It is a reversible reaction. If hydrogen peroxide is poured on a wound for cleaning the wound, hydrogen peroxide is used. The formula of hydrogen peroxide is H2O2. H2O2, hydrogen peroxide. If hydrogen peroxide is poured on a wound, it decomposes into water and oxygen. H2O2, hydrogen peroxide, it decomposes to form 2H2O, water and oxygen. It decomposes into water and oxygen. Water and oxygen. The gaseous oxygen bubbles away as it is formed and thus prevent the formation of H2O2. Prevent the formation of H2O2. This is a forward reaction. This is a backward reaction. 2H2O2 to form 2H2O and O2. The 2H2O combine with the oxygen to form 2H2O2. The formula of hydrogen peroxide is H2O2. This is a wound. The hydrogen peroxide is used to clean the wounds. The hydrogen peroxide. Irreversible reactions. Next, irreversible reactions. The reaction that cannot be reversed is called irreversible reaction. The irreversible reactions are unidirectional. That is, they take place only in the forward reaction. Consider the combustion of coal into carbon dioxide and water. Combustion of coal. Carbon is a burn in the presence of oxygen to form carbon dioxide plus heat. The reaction that cannot be reversed is called irreversible reaction. The difference between a reversible and irreversible reaction. Reversible and irreversible reaction. It can be reversed. The reversible reaction, it can be reversed under suitable conditions. Irreversible reaction, it cannot be reversed. It can be reversed under suitable conditions. Irreversible reaction, it cannot be reversed. The reversible reaction, both forward and backward reactions take place simultaneously. In the irreversible reaction, it is unidirectional. It proceeds only in the forward direction. It attains equilibrium. The reversible reaction attains equilibrium. The irreversible reaction is not attained. In the reversible reaction, the reactants cannot be converted completely into products. The irreversible reaction, the reactants can be completely converted into products. The reversible reaction, it is relatively slow. Irreversible reaction, it is fast. The important points of a reversible reactions are, it can be in the reversible reaction, it can be reversed. It cannot be reversed. Both forward and backward reactions take place simultaneously. It is unidirectional only. It attains equilibrium. It attains equilibrium. Equilibrium is not attained in the irreversible reaction. The reactants cannot be converted completely into products. The reactants can be completely converted into products. The reversible reaction relatively slow. Irreversible reaction is fast. Thank you, students.